plus x. So 2 plus x for the radius. The height is still top minus bottom, which is the square root of x, times the differential dx. So all four of these were rotated around a vertical line. However, the only thing that changed from one integration setup to the other was the radius, the distance away from the axis of rotation. All right, let's try some horizontal ones. Let's take the exact same region and let's rotate this around the x-axis. Now, if we are rotating around the x-axis, that means that we're going to need horizontal rectangles. If we are using horizontal rectangles, that means we need to be working with y's. So our formula is going to be 2 pi times the integral from a to b of r times h times our thickness, which in this case is going to be dy. Alright, so our y values, the y values are going to range from 0 to 2. So we're going to have 2 pi times the integral from 0 to 2. Now the radius this time, once again, the distance from the axis of rotation to that rectangle, that distance is a y distance. So the radius is y. Now, to get the height of the rectangle, since it's laying on its side, the height of the rectangle is going to be the right side minus the left side. Now, the right side is over here at 4 minus the left side. Now, remember that we were told that y is equal to the square root of x, which is true. However, we can't put the square root of x into our integral because we're integrating with respect to y. So what we need to do is to solve for x, and we're going to say that that inside radius, the left side, is going to be y squared. So the right side is 4, the left side is y squared. And then we have the differential dy. Now, once again, the important part of this, the portion that we need to be looking at, is going to be the setup. Once you get the setup, then I'm going to allow you to use the calculator to go ahead and plug in the values and integrate it. Although, remember, you do still need to be able to integrate. All right, so let's revolve this one around y equals 3. Here's the line y equals 3. Once again, if we have a horizontal axis of rotation, that means we need horizontal rectangles. So if we're working with horizontal rectangles, that means volume is going to be 2 pi times the integral from a to b of r times h times dy. And just like with the vertical rectangles, the only thing that's going to change from one form to another is the radius, the distance from the axis of rotation to the rectangle. We still have the 2 pi as part of the formula. We still have the limits of integration going from 0 to 2. However, the radius, which is the distance from the axis of rotation to the rectangle, that's this piece right here. The distance from the axis of rotation to the rectangle is going to be different than what we had up revolving around the x-axis. Now for this one, what I'm going to do is I'm going to find the distance from the axis of rotation back to the x-axis, which is 3 units, and then I'm going to subtract out this bottom distance of y. So the radius is going to be 3 minus y. 3 units to get back to the x-axis, and then minus y. So 3 minus y is the radius, and then the height is going to be the right side, which is 4, minus the left side, which we're using as y squared. And then times the differential dy. Okay, the last one I have for us is revolved around the line y equals -1. Y equals -1 is going to be down here below the x-axis. Once again, we have a horizontal axis of rotation, which means that we will have a horizontal rectangle. If we are working with a horizontal rectangle, we have 2 pi times the integral from a to b of r times h times the thickness, which is dy. So the y values are going to go from 0 to 2, so 2 pi times the integral from 0 to 2 of the radius. Now, once again, the radius is the distance from the axis of rotation to the rectangle. Now, in order to do that, we know that from here to here is 1, and then from here to here is y. So the total distance from the axis of rotation to the rectangle is going to be 1 plus y. And the height of the rectangle is right minus left, so that's going to be 4 minus y squared, and then our differential of y. Now, remember that the shell method is going to be an alternative way to solve for your solids of revolution. What this allows you to do is to choose what direction would be the most beneficial for your rectangles. Instead of being forced to always make your rectangles perpendicular to the axis of rotation, shell method allows you to turn the rectangles and make them parallel. So between disk, washer, and shell, you should be able to get the rectangles in whatever orientation will make it the easiest to find the volume. All right, so what I would like for you guys to do is try a few of these on your own. On page 472, I would like for you to try numbers 3, 7, 13, 19, 21, 23, 25, 27, and 28. And I will answer any questions that you have on these the next time I see you in class.